Hi everybody. We're going to work on a skill in Algebra 2 called evaluating functions, but before we do, I wanted to kind of back up a little bit and see if we can figure out what's the purpose of evaluating functions and what do we get out of it, and somehow or another I'm going to connect that to graphs. So again, this is a summary of what we talked about in class. We'll see if this puts all the pieces together and makes more sense for you. We have a function. I just arbitrarily picked a random function, 8 minus 1/2 x, and suppose I wanted to evaluate f of negative 2, f of negative 1, f of 0, f of 1, and f of 2. Remember, this is not multiplication here. What we're doing is we're saying, what is the value of the function when x is negative 2? You see the x is replaced with negative 2. So to evaluate, just as it says, I'm going to replace the x with negative 2 and see what the value of the function turns out to be. I started with x equals negative 3 because we did this as a class activity. But when I put in negative 3 for x, I have 8 minus, 1/2 of negative 3, and that becomes 8 plus 1 1/2, which is 9 1/2. So what have I done by evaluating the function at f of negative 3? I have discovered what's called a solution to the function equation. Specifically, the point negative 3, 9 1/2 is a solution to f of x. The reason being, if I put in negative 3 into this variable for x, and if I put in 9 1/2 in for the y, I'll have a true statement. Both sides will be 9 1/2. So I've identified one of the solutions to this function equation. Now in class, we all took turns evaluating at a different value, and we ended up with the following table of values. So here we see the independent variable x, and all the different corresponding x's have a y value to go with them. And so we have now 1, 2, 3, 4, 5, 6. I have 6 solutions to this function equation. Suffice it to say, you can come up with infinity solutions, because if you can pick a number for x, of which there are infinity choices, then you can find a number for y to go with it. So I could sit here all day, all month, all year, and list solutions to this equation, and I'll never actually get there. But you see, here's the thing. All of the solutions to a function equation can be represented as points. For example, negative 3, 9 1/2. Starting at the origin, we go negative 3 on the x-axis, and then we go up 9 1/2 on the y-axis, and we put a point there. So that one point is a representation of the first solution that I found. Negative 2, 9 is another solution, and another, and another, and another. And it doesn't take long for us to realize that all of the solutions to this specific equation fall on this line. So one of the ways that we can graph a function is to find a whole bunch of solutions, plot those solutions, and then we can make an educated guess as to where are the rest of the solutions going to be. Just to show you what I mean by this, if I have a point on the graph, and here, oops, I didn't mean to do that. Here is a point on the graph, and that is the point negative 4, 10. So I now know that if I put in negative 4 for x, the y value is going to be 10, because that's an extra point on the graph. I didn't have to put negative 4 in and do all this table work. I can see that the graph says negative 4, 10 is on this line, therefore negative 4, 10 will be a solution to this equation, which in fact it is. So one of the things we're going to do in algebra is we're going to be given function equations, and our job is going to be to show where all the solutions to that function equation exist. That's called graphing. In other words, if I graph a function, I'm creating a picture of all the solutions to that equation. There is the statement. A graph of a function is a picture of all of its solutions. It's a very big idea. Now here's the problem. Suppose I have a more complicated function, like the one you see here. This is x minus 3 divided by x squared minus 7. And when I look at that, I see that I'm going to need to get a few solutions so I can figure out what maybe the graph is going to look like. So in the same way as I did with the more simple equation, I can evaluate the function over and over and over again by hand. F of negative 4, for example, I put in a negative 4 for x here, and also here at the bottom, so they're both negative 4s now. Negative 4 minus 3 is negative 7. Negative 4 times negative 4 is positive 16 minus 7. This gives us negative 7 over 9. So then I know that negative 4, negative 7/9 is a solution to f of x. Now, it saved us the trouble, and I found all of the rest of the solutions to this equation, and I got them here. And then what we're going to do is we're going to take all of these points, and we're going to put them on a graph, and we'll see if we can figure out where all the rest of the solutions are going to be. So my proposition is, if we just have a long enough list of solutions, can we figure out where all of the rest of the solutions are going to be? So in class, we plotted these points, and this is the resulting graph. I looked at those points, and they seemed a little scattered to me. Granted, this section here seems to be in sort of a trend, but something goofy's happening here. But all I can think to do to find a graph with the points that I have here is to just connect them all. So I'm guessing that the graph is probably going to look something like this. I don't know. If I put the graph into the graphing calculator, here's the function equation. This is actually the whole graph. So these are the points that I plotted, and this is what the whole graph looks like. What I'm trying to demonstrate here is that plotting points to show the graph of all the solutions to an equation, sometimes it can be real easy because all the points fall in line. But most of the time, plotting points is time-consuming, it's tedious, and the fact is, even if you get this many points, it still doesn't mean you're going to end up with an accurate graph. So the two takeaways here are, number one, what is a graph of a function? And that's a big one. You have to remember this because a graph is showing a picture of all solutions to an equation. One of the skills we're going to develop in Algebra 2 is the ability to graph a variety of different kinds of functions. But because plotting points is tedious and not necessarily effective, we're going to have to learn to study functions in a more sophisticated way so that we don't have to work so hard to gain so much information. So this shows that we need to learn more about functions. We can't just plot points out to find where all the solutions are and just guess, because it's not always going to work for us. So I hope this makes sense to you. On the next video, which was associated with this, I'm going to talk a little bit more about the practice of evaluating functions, proper notation to use, and so forth. So stay tuned for that one. Thanks for watching.